first you need to make sure your calculator is in the correct mode. Please click the mode button. Please make sure that the word degree has been highlighted. While you're doing that, I'm going to pull my calculator up. So just click mode, make sure degree is highlighted, and then get out of it. This is page 74. I'm going to pull up an old warm-up question. Okay, look at this old warm-up question. Of course, this was tangent, but look at it. This was when we were using trig to solve for a missing side, right? If you have two sides of a right triangle, you can use what to find the third side? Pythagorean theorem. Remember this? Y'all with me? We're trying to tie it all together. Okay, if you have one side of a right triangle and one of the angles, you can use trig. How did we know when we were using tangent? We said if you draw an arrow to the hypotenuse and it's blank, then you knew it was tangent. The first day I taught you tangent, I pointed out the tangent problems. I didn't let you try to decide which one to use. Then I taught you sine and cosine. And we learned that with sine or cosine, if you will label your hypotenuse and then the other side based on the angle, you would know which trig function to use. Remember all this? Okay. And all three trig functions, sine, cosine, tangent, we have used to find a missing side of a triangle, right? Yes? Okay. And yesterday, we refreshed your memory on setting up all three of them by doing the around the room thing. And we had a warm-up also that reminded you, you set it up, trig function, angle measure, equals, fraction bar, and the fraction gets filled in based on the formula. Yes? Okay. Where am I going with this? We're going right here. Let's ease into it. How would you solve the equation 3x equals 12?
Divide by 3 from
Okay.
both sides.
So I want you to show you would divide by 3, you would get x equals 4. And the reason you do that is because division is the inverse of multiplication. Do you know what another word for inverse means? Opposite. So if you like the word opposite, you can write that if you want. But division is the inverse of multiplication. So how would you solve the equation x plus 6 equals 10?
Subtract the 6.
You would subtract 6, x would be 4, and that's because subtraction is the inverse of addition. Now, where am I going with this? Well, look at the title of this sheet. What are we solving for now? We're no longer solving for sides. Now we're solving for an angle. Look at the picture. I do want you to make an adjustment on here. Remember that variable at the very beginning of this unit, and we said this variable represents a missing angle measure? What was that variable? Do you remember? It's a Greek letter. Theta. I want you to somehow make this x right here into a theta. You just need to make it go over it completely, whatever you need to do. I want you to put a theta there. Notice this picture, the variable is now theta on the inside. We no longer have an x on the outside. We have a variable theta on the inside, okay? We are still going to use trig. And the beauty of it is what you already know how to do. It's just to solve it is slightly different, and it's actually easier than all of the other methods. Y'all thought sine, cosine, and tangent was easy? Wait till I show you inverse trig. Okay? So looking at this picture right here, I have some notes to take. We're going to draw an arrow from the right angle to the hypotenuse, and it is what? It is blank. I want you to write the word blank, because when the hypotenuse is blank, you're using which trig function? Tangent. Now I want you to label the rest of the sides of the triangle based on this theta right here. So 7 would be opposite, and 6 would be adjacent. We're going to solve for theta right now. You set up the trig ratio the normal way. Which trig function did you say? You said tan. All right, so tangent. What's the angle this time, though? Theta. It's theta. Equals fraction bar. What's the formula for tangent? Opposite over adjacent. So 7 over 6. Right? Okay, so if I say set up your trig function, that's what I'm looking for right there. New part is that this is actually good. This is your variable. That's the new part. All the others, the variable's been over here. We did the little elbow arrow, remember? Okay, we don't want to do that here because the variable is actually theta. Now here's the problem. Tangent is attached to theta. It is not attached by multiplication. You think it might be because they're just shoved together. It is not attached by multiplication. It's attached because it's a trig function. So the only way to move this is by its inverse operation, which, watch, is literally the same function, but it has a little -1 right there, and that means inverse. Now, what happens in math? When you do to one side, you got to do to the other. So I have to come over here and do it here. Red means wrong. You don't want to come after this and write times tan -1. You don't want to do that. Because the tan little -1 has got to go in front of the fraction. So here's the way that I do it. I set up my trig function in purple. And then I say to myself, okay, this has got to go, and it's going to pop right over here to the other side. And then I bring the rest down. So theta comes down, 7 over 6 comes down. And that's exactly what you type in the calculator. So you'll notice the green tan inverse that I applied on the left cancels that one out. And then it appears on the right because you have to balance it. Now, we need to take some notes, though, before we go to our calculator. Come right here. I want you to write tan inverse. Then I want you to draw an arrow to the -1. And I want you to write the word inverse in quotes. That does not mean tan to the -1 power. That actually is read tan inverse. Okay? The little -1 means, hey, this is the inverse of it, which means it's the opposite. Which means you just have to push the second button on your calculator before you hit the tan button. We are done. We're ready to go to our calculator now because now the variable is by itself. I need to know what this is. So you go to your calculator. Watch how you type it in. Because it is inverse, you push the second button. Then you go to tangent. You'll notice above tangent, you'll see the inverse one. Push it. You'll even see it pop up. And now you type the fraction. 7 divides 6. Enter.
Do you know how to do theta?
That's what
We're finding theta,
Oh, okay.
right?
What is that?
A fancy X. So let's go. I think I went to 2 decimal places.
So when they write 0, they put that.
It would just be.
What?
Did you say X or Z?
I said it's a fancy X. So the degree is 49 point. Let's go to the nearest 10th. 4. So theta is 49.4 degrees. Why did I put a degree symbol? Because it was an angle, not a side. Big difference, right? Huge. Big difference. Make a note. Come over here.
It's harder than it was.
No, it's not.
Yeah, it is.
Yeah, it is.
It is not, first of all. And second of all, I haven't even turned you loose to try it yet. So you cannot judge it.
It's about your mindset.
Thank you, Harmony. In
Harmony,
the
you just said you
calculator,
did
it was second, what was it? It was second tan, the little -1 pops up, and then it was 7 divides 6. That's what you type in the calculator. Now, look at the next part. It says, find the angle measurement represented by the given variable. Let's remind yourself right here. The given variable is theta, which is just a fancy X for an angle. All right, so we're putting together all three. Let's do number 1. Label your triangle first so you know which trig function you're using. Draw an arrow from the right angle to the hypotenuse. I have something here, which means I need to label it. Now, if there's something there, that means it's either sine or cosine. How do you figure out which one it is? You go to theta, and you ask yourself, how is that other side not labeled positioned to theta? How's the 10 positioned to theta? It's opposite. Label it, because then it will clearly tell you which trig function you're using. In fact, let's go to the very top of our paper and let's copy all 3 trig functions down so that you're not having to look over here at the board. Sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. And tangent theta is opposite over adjacent. All right, so coming back to the bottom, which trig function am I using here? I'm using sine. Okay, set it up. Watch. Trig function. What's the angle?
Theta.
Equals fraction bar. What's the fraction? Recognize where your variable is. My variable is theta, so what's got to move? Sine has to move. Sine is going to move to the other side as an inverse, right? The rest comes down. Now you go to your calculator. second sine 10 divided 12. Go to the nearest tenth. What'd you get? 56.4 degrees, right? Okay, let's do number 2. Label the picture. Stay with me. I'm telling you, you're gonna get left behind if you're not working. Label the picture. We've got a hypotenuse and a what? We have an adjacent. So which trig function is this? Cosine. So cosine theta equals, what's the fraction? So what am I typing in the calculator? Second cosine. Did you get 75.5? Okay, now I want you to go to the back and I want you to finish. This is a grade. You're going to the nearest tenth. When you get done, you're going to come check your answers and get your 300. You're welcome. Then we're moving on. Now that you have successfully practiced finding a missing angle using trig, the paper that you picked up off the corner of my desk is page 75, and it is, look at the title, which means we are now putting together both, if it's a missing side or if it's a missing angle. And they're all mixed up instead of being labeled like, hey, here you're solving for sides and here you're solving for angles. Now they're mixed up. So here's the big question that I get all the time. How do I know when I'm supposed to use the inverse, which is what we just did? And how do I know when I'm doing the whole side, the elbow arrow thing from before the break? On this paper right here, 74, I want you to come right here in the middle, and I want you to put in either highlighter or a colored pen, or you can box it in so it draws attention to it. Stand by for dramatic effect. If the variable is, now watch how I write this, in side. If it's inside the triangle, then use inverse trig. That's what I want you to write. If the variable is inside the triangle, then you're using inverse trig. And you'll notice I wrote the beginning of those words the same to show you the connection. How do you remember when to use inverse trig? When the variable is inside the triangle. Okay? So now go to the new paper that you just got, page 75. Let's copy the 3 trig functions to the top of that paper. That's not it. Hold on. Copy the 3 trig functions to the top of the paper that you just got. I'm pulling it up. Hold on. page 75. Over here, let's copy sine. Opposite over hypotenuse. Cosine. Adjacent over hypotenuse. Tangent. Opposite over adjacent. Please take note of what it says to round to on this whole thing. What's it say to go to? Oh, 2 decimal places. Y'all have got to practice with your rounding because that was what a lot of people got wrong on the quiz. Remember, if we're going to 2, we check the third. Don't domino round either. So it's just you check the third. If it's 5 or higher, then you round it. If not, you leave it alone. So look at number 1. Before you decide if it's trig, regular, or inverse trig, label your triangle. Label it. So draw an arrow to the hypotenuse. You got hypotenuse here. Then go to the angle and ask yourself, how's the other side positioned? It would be what? How's the 10 positioned to the 35? Opposite. So which trig function is this? This is sine. Doesn't matter if it's inverse trig or not. It's sine, right? That doesn't change. My 2 that like to not write anything, I need to see your trig function, okay? I want to see it. You with me? You're going to write it. Okay. So you're going to set it up. Trig function. Angle measure. Equals. Fraction bar. What goes in the fraction? 10 over x. Now you ask yourself, is this the new stuff? Or is this before the break?
It's old news.
This is old news, which means it's the elbow arrow. You're going to cross multiply the bottom of the fraction over here to the front. Sometimes you're done, sometimes you're not. In this case, we're not done. Then you would divide the sine 35 to the right. So that's going to divide out over here, and that's what you type in your calculator. We are going to 2 decimal places. Stand by, because I don't remember what the answer was. 43. Yep, 0.43. So x equals 17.43. Do I put a degree symbol?
No.
Thank you. Please pay attention. Don't put a degree symbol unless it was a missing angle. All right, let's go to number 2. Label your picture. You've got a hypotenuse, and you have this angle here. And how is the 16 positioned? Opposite. So we got sine again. Set it up. Trig function. What's the angle? A, right? 8 degrees. Equals fraction bar. 16 over 19. Where is your variable? It's inside, so it's inverse, which means sine bumps to the other side using inverse trig, and that's what you type in the calculator. And this is an angle, so we do put degrees. And you get, yep. Okay, this is a grade. You need to finish it by the time you come to me tomorrow. No, there is no flex tomorrow. However, you saw how fast you worked through your inverse problems. The other problems are there to remind you how to do it because when is your test? This week.
Thursday.
Yes.
Or
There's 20.